okay? A couple of other vocabulary terms are different types of equilibrium. You can have a homogeneous equilibrium or a heterogeneous equilibrium. You can probably figure out what that means, right? Homo would mean they're the same. So substances are all in the same phase. So reactants and products, substances in same phase, meaning like gas or aqueous or whatever. And if it's heterogeneous, substances in different phases. So that would be like if I have gases and liquids in my reactants, something like that. Okay. Now there is an important thing to remember about, especially things that are heterogeneous equilibriums. When I write a K equation, so my big K equilibrium constant equation for a reaction, we actually leave out liquids and solids. Leave L and S out of K equations. This is super important. Now, why do we do that? Technically, solids and liquids in a reaction aren't going to affect the equilibrium because there's so much of them there. There's actually not a concentration of a solid. It's just the solid. There's not a concentration of a liquid, just a liquid. Only aqueous and gaseous things should be involved. So if you look here at my example, this reaction here, I'm doing it in a bell jar, right? I've got CO2 as a gas, and my CaO and CaCO3 are both solids. So really, no matter how much solid I have in there, the equilibrium is only based on the CO2. So essentially these guys, because they're solids, should not be in my K equation. So I would write the K equation is, remember, it's products, so CO2, and I leave this guy out to, it doesn't have a coefficient, so no power, and I would leave this out. So it's really just based on the CO2 concentration. Okay, so solids and liquids are left out of the K equations. So now that we've talked about all of that, we've got example 2, 3, and 4 here. I want you to try these and then check back to check your answers. So pause. Okay, so I'm going to walk through these really quick, so check your answers. So A should have been the inverse because it's the reverse reaction, 0.0833. B should have been squared because it was doubled the reaction, so 144. And C was halved. Oh, sorry, that should be to the 1/2 power. Okay, and inversed. So if I inversed it, okay, so I reverted it, so I did 1 over, and I took it to the 1/2 power, which is really just the square root, I get 0.289. So it doesn't matter what order you do those in, you should get the same answer either way. All right, example number 3, I use that Kp equals Kc times RT to the delta N equation. So I put in my Kc value, gas constant, temperature, and then my delta N, remember, is the number of gas moles in the product. So 2, got 2 NOBRs, minus those in the reactant. So there's 2 NOs and 1 Br2 here. So this is 3 moles. So it's 2 minus 3. So it was -1. You should get 1.58 times 10 to the -4. All right, and then writing our equations. Remember, solids and liquids are not included in our K equations, so I left those out. So you should have gotten these 2. Good luck.